Welcome to AQA AS Chemistry. This is the 2015 specification, and it's 1.3, the arrangement of the electrons. You need to look at your textbook, and it's Oxford University Press, pages 8 to 9. The learning objectives for this lesson are to give the electronic structure of atoms and ions. So a quick revision of GCSE. So from GCSE you would have learned that electrons are located in shells, that the electrons fill from the innermost shell outwards, and that the first shell can hold up to 2 electrons, and then any other shell will hold up to 8 electrons. So you would have had seen these written as shorthand notation or drawn out with the orbitals like this. So you might have seen it as 2, 8, 8, or you might have seen the circles drawn out with the crosses on. So we need to update our GCSE knowledge, because what you learned at GCSE was a simplification. So at A level, we're taught that a shell holds 2n squared number of electrons, where n is the number of the shell. So, for example, for the first shell, then it's 2 times 1 squared, which is 2 electrons. So the first shell will hold 2 electrons. The second shell is 2 times 2 to the power of 2, or 2 squared, which is 8 electrons. And for the third shell, it's 2 times 3 squared, which equals 18 electrons. Now it's important to remember this is a simplification. It's not as much a simplification as GCSE was, but it's still a simplification. And we will do the electron configuration in more detail in the 1.5 chapter. However, the reason we're still teaching you the simplified version is that simplified electron configurations are very useful for when you're doing things like working out geometries of crystals. If you're describing the bonding of atoms in molecules, if you're describing like ionic bonding or covalent bonding, then this sort of simplified electron configuration is very useful. And also for predicting the shape of molecules, which you'll meet later in the textbook. So they are still important, even though we know that they're a simplification. So how do you write simplified electron configurations? Well, there's 2 ways you can do it. First of all, you can do the shorthand notation, where you start from the innermost shell, you write the number of electrons in each shell, and you separate each shell with a comma. If you want to draw out the full electron configuration, then you draw a circle for each shell, you draw crosses to represent each electron, and you draw single crosses in the order starting at the top, so one at the top, one at the right hand side, one at the bottom, one at the left hand side. Then once you've done the first 4, you then repeat the order again, but pairing up the electrons. So again, you'd go top, then the right hand side, then the bottom, then the left hand side. You don't have to do this, and you wouldn't lose marks in the exam if it wasn't done in this order, but it just makes it nice and methodical, which means you can keep track of where the electrons are a bit more. It's easier to see what's happening at first sight. So let's do some examples of these simplified electron configurations. So first of all, lithium. So if you look in the periodic table for lithium, you'll see that its relative atomic mass is 7 and its atomic number is 3, so it has 3 electrons. So if you're going to draw out the simple shorthand electron configuration, there's 3 electrons. The first 2 can go in the inner shell, and the third one goes in the second shell. So if we were to write this out in shorthand, it would be 2, 1. If we were to draw it, it would just be drawn as this. So one circle with 2 crosses on, and then the second circle with just 1 cross on. So that's quite a simple example. We'll look at the next one, which is fluorine. It's slightly more complicated. So if you look in the periodic table for fluorine, it has an atomic number of 9, so it's got 9 electrons. So we know that the first shell holds 2 and the second holds 8, which is 10 electrons. We've got less than 10 electrons, we've only got 9, so that means we only need 2 shells. So if you write this out in shorthand, it would just be 2, 7, or 2, 7, sorry. Now if we were to draw the shells out, we know there's 2 shells, so we'll draw the 2 circles. We then do the first electron in the inner shell, the second one in the inner electron shell, and then we said we'll do it in the order that we described on the previous slide. So we'll go top first, then the right hand side, then the bottom, then the left, then back to the top, back to the right, back to the bottom. And that gives us 9 electrons. So that's the drawn out electron configuration of fluorine. So we do get some useful information from the electron configuration, which you may have covered at GCSE. So the number which is the furthest to the right, if we're talking about shorthand notation here, so if you've got something like 287, so the number which is the furthest to the right is the group number, and the number of numbers is the period number. So let's look at an example. If we had the electron configuration of 2, 8, 4, then the number which is the furthest to the right is the group number. So the number furthest to the right is 4, which means this element is in group 4. And the number of numbers is the period number. So we have 3 numbers there, so the element is in period 3. So we know from looking at that electron configuration that this element is in group 4 and it is in period 3. So back to our learning objectives, which was to give the electronic structure of atoms and ions. As usual, if you feel you can do this, then you're good. If you don't feel you can do this, either rewatch the video or look at the textbook, but make sure you can understand it before you come to lesson. And if you are watching the Office mixed version of this video, then on the next 4 slides, there will be some multiple choice questions for you to do.